Welcome everyone to our session on non-fungible token module development. So in the recent years, NFT have gained significant attention as a revolutionary technology that has transformed the world of digital assets, from artworks and collectibles to real estates and gaming items. NFT have opened up a new realm of possibilities for ownership and blockchain. In this session, we'll dive into the exciting world of NFTs and explore the fundamentals of developing an NFT module within the Cosmos SDK ecosystem. Whether you are a blockchain developer looking to expand your skill set or an enthusiast interested in understanding the inner workings of NFTs, this session will provide you with valuable insights and practical knowledge. As we have already understood the core concepts of NFT, including their characteristics, unique identifiers, and their underlying technologies that make them possible for our previous workshop. So now we'll explore the key components and functionalities required to create an NFT module, such as defining NFT structures, implementing minting, transfer mechanism, managing metadata, handling queries, and transactions. So by the end of workshop, you'll have a solid understanding of NFTs, their significance in the blockchain space, and the practical steps involving the development of NFT module using Cosmos SDK. You'll be equipped with the knowledge to embark your own NFT development journey or contribute to existing NFT projects with the vibrant ecosystem of Cosmos. So let's get started on this exciting exploration into NFT module development. So as we decided in the previous workshop, that similar to the workshop of Cosmosm, where we in the NFT we first initialize a collection. Inside the collection, we'll have multiple NFTs, and those NFTs will be facilitated with CRUD operations, all the create, delete, burn, and all those operations related to each NFT. So we'll start with that. So before that, we need to just structurize our code. So in the module, we'll use protobufs. So basically, what are protobufs? So protobufs, short for protocol buffers, are a language agnostic data serialization format that's developed by Google basically. So they are widely used for efficient and reliable communication between different systems and components. So protobufs in Cosmos SDK offer a compact binary representation of structured data, making it fast to serialize and deserialize and provide backward and forward compatibility with involving data schemas. So that's the one reason that we use protobufs to define structures in our Cosmos SDK. So yeah, in the context of Cosmos SDK, which is a framework for building blockchain application, which you might know, protobufs are used for defining messages and transactions that can be sent and received by various modules within the SDK ecosystem. So we look into the use cases of protobufs in our Cosmos SDK, first of all. So first one being module definition. So each module within the Cosmos SDK defines its own protobuf messages that define the structure and format of the data it handles. So these messages can represent transactions, queries, events, and or any other type of data relevant to module functionality. So we can use protobuf for that. So second is inter-module communication. So protobuf messages are used to facilitate communication between different modules within the Cosmos SDK. Modules can send and receive messages defined by the other modules to interact and exchange data within each other. So next is state persistence. So protobufs are used to serialize and store the state of the blockchain various modules. Okay, by defining protobuf messages for storing state data, the Cosmos SDK can efficiently serialize and deserialize the state, allowing for efficient data retrieval and manipulation. And the last is interoperability. Protobufs enables interoperability between different blockchains, network, and application. So by using the standardized data format, Cosmos SDK-based application can basically communicate and share data with the other system that supports protobufs and all. So making it also makes it easier to integrate with external services and exchange data with other blockchains too. So these are basic use cases of protobufs in Cosmos SDK. So overall, protobufs in Cosmos SDK provides a structured and efficient way to define and handle data within the blockchain framework. They enable seamless communication between modules, efficient storage of data, interoperability with other systems, enhancing the overall functionality, basically the versatility of the Cosmos SDK ecosystem. So these are the basic use cases of protobuffs that we went through. So yes, next we'll define the proto definition for our NFT module basically. So what are the structures that we're gonna use for to define our NFT entire NFT module? So as I discussed, we'll have a collection, and in turn connection will have NFTs and different NFTs in between a particular connection. So first step we'll have to define a collection. So collection here you have seen that as you can see that I have written as denom. Basically denom represents a collection, a single collection. A collection has specific fields. These fields are a specific ID of a collection, a symbol associated with it, name, additional description, URI. So this preview URI basically used to represent in the in the UI that like the URI will be used to represent this NFT in the UI front. So that's what we need to provide the URI. So a schema basically JSON schema for any additional properties that we want to set up. Sender and the creator of the NFT, that NFT, the basically the creator of the collection, who is the creator of the collection, will store the address of that. So that's what we use these structures for that. And the next for NFT will have similar to collection, NFT will have a unique ID and the metadata associated with that NFT and additional data that additional properties of the NFT, which will be an optional field. Certain fields are basically required field and certain fields are optional field. We'll see the use of required and additional field as we move forward with the module development part. So these transferable, extensible, these are the features that we want to make the NFT as a transferable or extensible or not. And the owner of the NFT will just store the owner of the NFT address, basically the address of the address of the owner of the NFT. We need to store created the timestamp at which the NFT will be created, royalty associated with the NFT. So these are these are the parameters that will be used for defining the NFT, a particular NFT. Similar to collection and NFT will have a metadata. For the metadata field also, each metadata will have a name associated with the description, same media and a preview URI for that, for displaying in the UI front. And the other collections, like other structs that we use is a collection, which we can say a particular collection ID. Inside a collection ID, we can have a multiple NFT. So there you can see a repeated field. Repeated just means this array of NFT basically associated with a particular denom. So that's what it is used to store. And similar to that is ID. Basically, just with a particular denom ID, we can have multiple NFT ID that has been created. So we can store that. So these are basic structs that we are going to use throughout our module. And yeah, these module features basically will be all the CRUD operation, basically minting, transfer of the NFT, burning of the NFT, and we can update the NFT. Basically, the owner of the NFT, the creator basically can update the NFTs. So these are the basic features that we're gonna look forward with that. And yes, so we'll go one by one. Let's go one by one to the Okay, so now we'll see how we can use this proto definition in our module and we can generate the proto files and all. So let's go back to the code. In the previous workshop, you might have seen that we can generate the module using the ignite command to generate a module, and we can initialize and set up the module in the app.go file that we did in the previous workshop. So now what I'll do in the proto file, you can see inside context, inside NFT, one beta one. I'll create a file name, for example, denom dot, sorry. So yeah, here is the first proto that we're gonna do it. We just create a file called denom.proto and we'll start with it. First of all, we need to provide a syntax and a package name for it. So we'll use the syntax as proto 3. So this will be common. And the name of the package also as package will be complex dot nft dot v1 beta 1. So you can see inside proto we have complex then NFT, then inside NFT, V1 beta 1. We define the package of that. So as we saw earlier, we need to define these structures. So we'll start with denom, basically. So to start with it, I'll use message denom and define each and every parameter associated with that denom. We'll start with ID. First is the ID, and the second is the symbol. Third one was the name. Then the description of the denom. The fourth one is the preview URI, basically. Just a second. One is that. And that preview URI will have some more tags and customs tag associated with that. So this, I'll just use that and I'll explain what does this mean further. I'll explain what does this mean, more tags and custom tags associated with GoGo Proto. So let's complete it, the structure part first. String, define the schema of that. Schema just basically means the additional properties associated with that denom. We can have it or we cannot have it. Sender and creator. We have two fields, sender or creator, because just a second. Yes. So the sender is the one who will initiate the transaction to create that this collection, and the creator, you can have the sender can be the creator, but he can create the denom on behalf of other. So he can specify the creator address on behalf of him, because the sender can be XYZ and other can be ABC. So he can create the denom on behalf of other. So that's why we use two different fields for sender and creator. So you can see here it throws error because it does not find it. We'll import it. We'll import it. Yeah. So here is a structure ready, basically for the collection. We'll just name it collection. So this one is ready. Now we need to interact with it. So we need to generate PB files for it. So what does PB file means? So the PB files are basically refers to the code generated files from protocol buffers definition with .proto extension. With when you define your messages or services or any other constructs in your .proto file, you can use various protobuf code generation tools to automatically generate corresponding codes for different programming languages. Like here we use Go, so we use Go here. The generated PV file will contain the Go code. So basically, it will contain the Go code that represents your protobuf messages, what the messages that you have specified here, along with additional code for serialization and deserialization. So these codes are automatically generated by that. So you don't need to write the deserialization serialization code by yourself. It's automatically generated. And other utility functions also. These files are essentially for working with protobuf messages in Go and allows you to interact with these defined messages and structures, perform encoding and decoding operations, manipulate the data according to your application needs. So that's what you can do it. So now what we'll do, we'll just create it. Just a second. So, and yeah, these PB files where it will be created inside and this module X directory where our module resides, X under types. Here the PB files will be created. You can see there are no PB files, only Go files are here. So now we'll create it. So for that, just a second. What we'll use, I'll just specify option bar. So where it will be created under types. So what I'll do, I'll use a script. So the scripts you can find inside script folder. protogen.sh. So this script basically used to generate the protobuf files. So I'll use .script / protogen.sh. You can see the script ran, and inside types I have denom.pb.go file here created. So what does this denom.pb file has? Just let's see. So you can see this marshalling and marshalling, basically the decoding and encoding stuffs that I explained some time back. So these are messages automatically generated by Go. So you can see here the package resides here. What kind of package is there? This denom.proto, whose messages are serialized and deserialized messages are written here. So encoding, denom, and all those things. So these codes are automatically generated. You don't need to take care of that. You just need to use it. So now, yes, we are done with the collection part, and the second is the NFT one. So we need to define the NFT struct here. So the same thing we can do for as we created for collection, we can use to create an NFT for that, NFT struct. And same thing, it will have string ID equals 1. And then we'll have a string data equals 3, 2, sorry. And similar to all the fields that we discussed here, we can have a string, metadata, bool functions, and these features. So I already have the code. I can just use it. So you can see the string, the metadata field, the data owner, the transfer, if it is transferable or not, extensible, if NFT will be extensible or not, the timestamp, keys, and all those fields that we have discussed, we have mentioned here. So we'll use the same command to generate the PB definitions for it. You can see now it throws a two error, like it cannot find the metadata because I have used metadata here, but I haven't defined metadata. So what I'll do is to define the metadata field first. So yeah, I have defined here the metadata one, the name, description, and all those things that we discussed. I defined all the parameters associated with the metadata. Now I guess this error message will go back. Now we are left with one. You can see that protocol of the timestamp that we are using here. We are using, but we haven't imported it. So what I'll do, I'll import that. I'll import that here. Now I guess the PB files might be updated. Yeah, you can see. Now here, yeah, NFT. You can see the new struct, the PB definitions have been created for the NFT part. Same thing as we have seen for the collection one, it's same. For the metadata also, you can see the PB definitions have been created. So these are auto-generated code. No need to take care of that. Just need to use it. So yeah, now we have learned how we can create a proto file and we can create a PB definition file for the same, for which will be used for further in the module development to interact with it. So now we are done with it. We can yeah, we can use now start with the CRUD operations basically. So the first one will be to create an NFT. No, create a denom, sorry. So create an NFT denom, you need to use this command. So basically, this is the context, the binary name. TX means stands for transaction. It means we need to do a transaction on our complex blockchain. Which module? It is an NFT module. And what states? This is the function. That's the operation that we need to perform on that. This is the create operation. So now we'll see how we can write the PB definition for the create operation. The create operation will have a symbol, name, definition, and URI and schema. These things we need to put while creating a transaction for create. So we'll use it. Now what I'll do for the operation, I'll create one more file called tx.proto, right? So the tx.proto similar to this, we'll use syntax as proto3, sorry, proto3 and packages context.nft V1. So yes, now we'll start by defining the message structure. So to define the message structure, we'll use a message. This is the basic jargon that we use because we want to create a denom, right? Create a denom, okay? And the denom will have symbol, name, description, preview URI, and schema. These are the parameters that will be required. We'll use the structure for that. So for that, first we'll use basically this ID. ID will not will not take from the user. It will be used in the struct. So that's why I use ID here. But we load take ID. We just see if, further in the transaction and transaction command in the CLI commands how we'll write. We'll take the inputs of those. So these are the structure only we are defining here. Like here symbol. Symbol will take from the user what symbol he wants to associate it to name the his or her correction. And second is the string name associated with it. Description. Preview URI for it will be this one. Now same as we did because we want a preview URI to have some custom logos. Yeah, we'll come to this the details of what does more tags, custom tags, these all things means. We'll come to that. Sender. What's the sender? We'll just store who did the transaction basically, and we can have the name. Okay. Yeah. So you can see it still gives an error. So just because of it, we haven't imported the Google Protos. Now it goes back. Yeah. So now you can see this is a request message basically. And similar to that, we'll have a response. Basically, you can have any response for it because but right now we'll have just an empty response. Create demo, we'll have response. Yeah. So our transaction command for create denom is ready. Basically, not transaction, but transaction proto PV structure for the transaction is ready. So this will use, and for that we'll use a service message also. So associated with each and every operation. We'll have service message for. Now we'll register the service message for this create denom. So this is how we register it. Message create denom, which returns, what does it return? This response. So now you can see we have registered this. And same way as we did for the this file, denom.proto, we need to create a PB definition for it. So use the same command. Just a second. Oh, yeah, okay. I need to provide the path also. Just a second. Provide the path where it needs to be. Yeah. So it ran, and you can see, yeah, tx.pb.go is created. So similar to that, it will have, yeah, you can see message create denom PB definition has been created, or the decoding and encoding stuffs had automatically been created by the PB definitions. So you don't need to take care of that. Similar to it. So yeah, our first message to create a collection basically is ready. So similar to that, we have other messages for update also, to transfer and to mint NFT also. So those messages also we need to just import it here. So what I'll do, I just use my messages and use it. Just a second. Just use one more first, then we'll use other. So you can see this is the transfer NFT part. So the transfer NFT part will have an ID, the denom ID associated with it, and the sender and recipient. The sender will be the owner of the NFT, and the recipient basically to whose address the NFT ownership will be transferred. The same thing we can have the service message ready for it. The same service message has been registered for it. Message transfer NFT, message transfer NFT, NFT response, I guess. Message transfer NFT. Message transfer NFT response. Similar to that, we can have for others also. So what I'll do, I'll just copy all and just paste it. So I have already written all the operations associated with the NFT: create, update, transfer of the denom, mint of the NFT, transfer of the NFT, and to burn NFT also. So all the messages associated with it I have mentioned, and what I'll do, I'll just run the script to generate the PP definitions. So you can see the PP definition files have been updated with all the messages that have been mentioned. To mint NFT, you can see burn NFT messages have been registered. So this is how you can register your messages in the proto files. So we'll come back here. All the applications. Oh, yes, it got that. So create when we saw mint NFT. So each NFT will be having associated features with it. So this is how you can. These are the parameters that we need to pass to mint an NFT. Transfer NFT, as we just saw, similar to that, and everyone will have an associated function message associated with it, like Comdex TX NFT burn. Similar, if you want to burn it, you need to use this command. To transfer, you need to use an NFT transfer command. So each and every CRUD operation have associated commands associated with it. Okay. So yeah, now we'll come back to this. What does this go proto tags and what does this means? So first of all, this thing. See, coproto.nullable is equal to false. What does this means? So coproto.nullable is an option provided by the coproto plugins, as you saw here. This Go Proto plugin for protocol buffers for the Go programming language. Basically, it allows fields in the protobuf message to be marked as nullable, which meaning that they can have a null or nil value, or they cannot have null or nil value. So here, as we saw, nullable is equal to false. So nullable is equal to false, which means it cannot have a null value. So this royalty share, this cannot have a null value or nil value. The generated Go code for this message would not include a pointer for this field. So that's why we need to mention it as a nullable is equal to false, which means cannot have a null value. Similar to that, we have this STD time. So this STD time option is another feature provided by this plugin for protocol buffers. It used to generate Go code that supports the serialization and deserialization of standard time types. So that's why we use STD time here, because we need to need to store a timestamp at which the NFT is being created. So that's why we use this field here. So the other one is the more tags. So more tags, you can see this struct tag in Go are metadata attached to the struct field. So providing additional information and instruction to the co-compiler or external libraries that we use. So they are typically used for the purpose of JSON serialization. That's why you use more tags here, and database mapping and validation and stuffs. And yeah, and one more thing that you saw is custom tags. So this royalty share will be basically a decimal field. So we'll have a royalty 0.1% or 3%. I can have a 3.4% or decimal field. So that's why we need to typecast it as a decimal. So this will accept only as decimal from this Cosmos SDK type decimal tag field. So that's why we need to mention it here. So here we have mentioned. So this is what's the use case of Go proto tags. Similar to it, we use only in the defining the structures of the R. So yeah, we have defined the structures for it. Now next step is basically we have went through the features, the transfer and active burn part, and now we need to see the results, basically the queries, or need to list out the denoms and list out the NFT that has been minted on the platform and all those queries associated with it. So we need to write query in the proto files. So for that also we need to utilize this proto. So for that, what we'll do, so here I'll create one more file as query dot proto. So similar to the structure as we followed, we provide a syntax as proto 3, package name will be same, context dot nft dot b1 beta 1. Okay. So yeah. So first of all, let's create a request for collection. So for example, this one, to list the denoms of collections or list the denom associated with a particular denom ID. So to make the query calls, what we'll do, yeah, we need to write a message for that. A message associated with query are preceded by query, just a jargon we use, collection request. Okay. Collection request will have a string which we need to take from the user, like what you are querying, denom. So yes, this is the denom ID, and this more tags will use here as we discussed earlier. Use case of the more tags. So this our first query structure ready, and we need to register this query also. So similar to that, the transaction part, we need to register query for the same. So we RPC for collection, and first of all need to register the service, service URY query. Okay. RPC for collection. We name the request as query collection request, which in turn returns. We need to write a return message for it. Collection response. Okay. You can see Go Proto, we need to import it. So what I'll do, I'll import the Go Proto. Now you can see this is ready for Go Proto. Yes. Similar to the transaction part, we have registered here. And yeah, and additional to that, we just use an endpoint associated with it. So endpoint will be used to query this collection basically. So we use google.api.h http calls dot get. We need to provide an endpoint for it. So we'll use context slash NFT, which is the name of the module. B1 beta 1. Okay. Slash will name as collection, and this represents that we need an input field to query it. So denom ID is the input field. We'll use that. And this is, we'll close that. We use an option field also to, yeah. Similarly, our first query command is ready to query the collection with the associated collection ID. So we'll generate the PB definition for the same as we did earlier. Now collection Google API extension, just a second. Google API is not found. We'll use Google API annotations. So I guess it might be created. Yeah, you can see query.pb.go definitions have been created similar to our transaction and denom part. This is a query collection request associated with the response. This has been auto-generated by the Go. So yeah, so here we define the definition of the structures. This is the query part, and this is the transaction. Similar to the similar to a transaction, sorry, I'll import all the queries associated with it. Hello. You can see I have all collection request. You want to request by the denom. You want to request all the denoms. So all NFT with a particular ID. So all the different types of queries listed we have mentioned here. Same thing we'll do. We'll update all the files associated with it. With this file also. We'll have collection, denom, and all those things associated with it have been updated. Now I guess I can generate the PP definitions. So the PB definition associated with all are updated inside query. All queries you can see query denom response, query denom request, all these things are updated. Transaction is also updated. So yeah, this way we can create a structure using protocol buffers, define the transaction and query functions in our module. So these will be further used for the model development when we'll start with store initializations, basically the keeper part, where all the logic associated with the NFT will be written. So I guess that's all for today's session.